Hello, everybody, and welcome to the 13th episode of the programming course. This is the first episode. I wear my glasses. Yeah, I know. Yeah, but today we're going to talk about a phenomenon that we haven't discussed it yet in this whole programming course, and this is uh, a bit more like a advanced programming thingy, but I believe that you must know it because all the things we have written yet, it's not saved anywhere, and we haven't been able to retrieve it from somewhere. So we don't have any database. That's what I'm saying. But we are not going to talk about databases yet because what I am intended to say in this course is what is threads and how we can use multi-threading features that we're gonna see later in this video. But you know, I want to delete them and start over for the threading things. And I want to show you what is threads, what it does, how we can make multi-threads, and what is the benefit of that. This is the questions I'm going to answer, but first thing first. Imagine a situation that we want to add up the numbers between 1 and 1 billion. This is a lot of numbers, right? But just imagine that we want to do it. So how could we do it? Let's write a function for it. I mean, we're gonna name it sum up, and as an argument I'm going to pass the what you say, that's the, if we want to sum up the numbers between 1 and n, we're gonna pass n. That is the finite point of a series. This is the last element that we want to add, so I'm gonna call it n. And for I in range of 1 up to n plus 1, what should I do? I'm going to imagine a result as 0 and add the result with this given I, and then I'm going to return the result. So let's test it. For example, if we want to add 1, 2, 3, 4 all the way up to 10, the result would be what? Would be 10, 11, 5, 55. Yeah. The result will be 55, but let's see. We're gonna call the sum up of 10, and I'm going to expect the result of 55. Let's see. Yeah, and the result is 55, and so it works kind of fine. But as we go up, for example 100, it's going to take a bit more. For example, let's imagine a huge number. It is going to, this is taking much more longer to answer because it is a harder job. I want to interrupt it, and let's go with 1 billion. This is 1 billion. Of course, you can separate the numbers by this underscore. This is for more readability thingy, and this same syntax could be used in Java. But yeah, it is taking 2 lines, but I can say half of 1 billion would be 500 million times 1 billion 1. this is the result, and if I go with 500 million times 1 billion, it's the result of something like that. Yeah, and as you can see, the same number goes here, so it works great. This is a mathematical solution, the Gauss guess. I believe this is the phenomenon that I used to sum up the numbers of 1 all the way up to n, but I'm not going to talk about mathematics here. So yeah, so this takes a long time, but this can work. I mean, if I copy this for 2 billion, and let's go with 5 million, yeah, it takes enough time to demonstrate that it is a really long word. Really, this is a huge task. So, for the million, it doesn't seem like huge. Let's go with 10 million, 50 million. Yeah, it takes enough time. This is. Oh, I wanted here to clear. Let's go with 100 millions, 200 and 500 million. So, it takes a bit amount of time to calculate each one, and this is a time consuming thingy. But the reason is all this work are happening in the same line, because there is only one thread. You can imagine this as a one queue or one line. All the tasks are in this very same line, and when it is summing up all the way up to 100 million, we are not able to this sum up or this other sum up. So the reason that it takes too long to answer all these three is just this is not happening until this is done. But with threading, for this return, I'm going to just change this to print and get rid of this print here. I mean, not just here, all this way. Okay, this should work like the same, but yeah, there's no difference. For the third thing, I have to import something called threading. So the threading is actually a library, and the library is just some classes and functions that we can use. We haven't discussed about creating libraries and stuff. Maybe we would. I haven't decided yet, but whatever. We are going to import threading because threading is not something that Python has out of the box. I mean, the package comes with the Python default installation, but there is no threading functionality without importing anything. So we have to import the threading part. So after that, we are going to make some threads. Threads are like these virtual queues that we can put tasks on each queue, and they are going to execute at the same time. They're going to be a parallel tasks. So instead of waiting to summing all these ones one by one, we can just start calculating them simultaneously, and not any of them are going to wait for the other one to finish. So just like that, this is going to be a real awesome thing. So we are going to make 3 threads for these 3 function calls. From threading, I'm going to call a function that named thread, and I'm going to pass two arguments. One of them is target, and the target is this sum of function, and the other thing that we can pass is, I believe, args. Yeah, the arg is the argument, so we have only one argument here. This is 100 million, just like that. I'm just going to make two other threads, T2 and T3, for 200 millions and 500 millions. So all I have to do is just start each thread, and T3 start, and if I run this code, this is a bit faster, at least if we go for the whole number. Okay, these tasks are running simultaneously and nothing is waiting for other tasks to be done. So if I want to demonstrate it a bit more fair, I'm going to use the same number in each thread, and these are going to give the result at the very same time. You see that we got the result at the very same time for each thread, and it's like boom. Yeah, just like that. But if we wanted to call them one by one, we have to wait for every let's test it. I'm going to exit here, but before that I'm going to call SumUp for 100 million 3 times. At this methodology, when I comment out these things here, we don't need those. At this methodology, we have to wait for each system call. The first one got the result, the second one, and now the third one, because they are always waited for each other. But since we use the threads, they are start working simultaneously, and at the very same time we have all the results. That's it. So the threads are independent queues that we can run in task on those queues without waiting for the other queues. This has some huge benefits, like the speed up the code and things like that, but it has some down points, but we are not going to talk about that now, because we are not ready for this time, task scheduling things and stuff like that. So after that, I'm going to print done, but as soon as I hit this play button here, you're gonna see that this is going to print down and then starts the thread. So it reached the point to write down, and then the threads went to execution thing like that. But this is not actually true, because the whole program has a main queue, and the main queue called the main thread or things like that. But we created 3 separated queues to 3 separated threads. Start using threads as the queue. So at the first and the main thread, we just wanted to write done. So that was the only thing to do, and it did done here, you see. But those other 3 threads started to work, and they took some time to calculate the things because they had a complicated job. But as you can see, it took it a bit of time to understand. But the reason that done has been printed first is this is at a totally different thread, and it's not going to wait for anything. If we wanted to wait for it, we just could to use the join method on the thread. The join method actually waits for the thread to stop. So as we hit the join, we never proceed, and the thread kind of waits here until the thread 1 finishes the job, and after that goes for thread 2 and thread 3. But since they are finishing the job roughly the same time, they are not going to wait for each other too long. They just you know, they just wanted to finish all this tree, and then it jumps to done. This join method kind of solves the problem here, and if I hit run again, as you can see, this is not going to write done at the very beginning of the script. It just waits for the results and then writes the done. That's what join does. But we not always want to join any thread to the main thread, but you know, sometimes we're gonna need it. It depends on the situation. So this is all I wanted to say about the threads, and you can just pass more parameters and stuff like that, but we're not going to talk about those yet. I just wanted to introduce what is threads and what is the benefit and why we use it, and I believe we have discussed that. So in the next episode, I might talk a bit more about databases and multi-threading things, and the reason that we have to use multi-threading things when it comes to database. But until that, take care. Bye bye.